My name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 287. Page number 287, and today is our lesson number 184. Problem number 133 is what we are about to solve. It says x, y and z are 3-digit integers. We are told that x, y and z are 3-digit positive integers. 3-digit positive integers. Okay, keep that in mind, it's positive. And we are told that the sum of the y and the z, which are both 3-digit integers, equals x. That's what it is. The question simply is the hundredths digit of x equal to the sum of the 100 digits of the other two numbers? That's what it is. Does the 100 digit of x equal to the sum of the 100 digits of the other two numbers? That's all. Let's see what that tells us. Now, before we actually look at the two statements to see what they give us, here's what we have to understand. What we need to understand here is that here's a solution. This part that they're asking here is the 100 digit of x equal to the 100 digit of y plus the 100 digit of z. That will only be true. This will only be true if what? If the sum of the 10 digits of y and z is something less than or equal to 9. This condition must be met. That is the only way the sum of the 200 digits is going to equal to the 100 digits of x. For example, if we have 2, 3, 4, let's say, and 3, 4, 5, let's call this thing y and let's call this thing z, and here's our x, and x would be here 9, 7 and 5. As we can see here, the sum of the 100 digits of y and z, 100 digit of y is 2, 100 digit of y in this scenario is 2, 100 digit of z is 3, and of course 2 plus 3 equals to the 100 digit of x, which is 5. But as you can see, this will only be true if the sum of the 10 digits of y and z is something less than or equal to 9. It can be as high as 9. For example, instead of 3 and 4, we could have had 5 and 4, and this would still be fine. But if the sum of the 10 digit of y and z happens to be something more than 9, well, then we got a slight problem there. Things are going to get prickly then. For example, instead of 254, if we had, say, for example, 274, well, now we have a problem. Because now 7 plus 4 is 11, this is going to become 1, and here we're going to have to carry 1, and this guy is going to have to turn to 6. And 6 no longer equals 2 plus 3. This is the 100 digit of y, this is the 100 digit of z, 100 digit of y and 100 digit of z, no longer equal to the 100 digit of x. This is a very simple concept, because you're going to carry over 100. So that's all it is. The sum of the 10 digit must remain something equal to or less than 9. It cannot go, in other words, it cannot go over 9. That's all it is. Now we are ready to look at the two statement. Okay? Let's look at the first statement. Sometimes in the data sufficiency questions you have to slow down, you have to step back and take a look at it in a more logical and rational manner. Don't freak out and don't try to have this uncontrollable urge. I need both of my hands to finish the sentence, because otherwise I can't finish the sentence. Many a times I have seen my clients, they have this uncontrollable urge to do the problem the proper way, mathematically, algebraically, academically. That is not what is required in all of these problem solving, all of these data sufficiency questions. Data sufficiency questions are very clever questions. A lot of the time they're simply looking to see if you can think rationally. That's all it is. If you watch the previous video, which we did on day number 182, the previous question that we did, 132, was a classic example of that. What is the classic example of what I'm talking about here, where no mathematical solution is required, you just have to think logically. The one that is coming up after this is another one of those. No, not the right after this, but 135 is another example of what one needs to do there. Because if you try to sit there and solve it in an abstract term, algebraically, you'll be there forever. To say nothing of the fact that most people will not be able to analyze it in abstract mathematical terms like a mathematician would do. Your math professor will be able to do that, in theory, with all the numbers and so forth, and give you mathematical proof. But that is not what they're looking for. These people are rational. These are not insane people. If they are expecting you to do the problem in 2 minutes, it must be something that can be done. They are rational. They are not irrational. Do you understand? Anyway, I'm done with my sermon, okay? Amen. Let's see what they give us in the first statement. In the first statement, they tell us the 10 digit of x is equal to the sum of the 10. Oh, what do you know? What the hell? That's exactly what we're looking for. In the first statement, they tell us exactly what we got done discussing here. That the sum of the 10 digit of z, y, and z must equal something less than or equal to 9. Which is exactly what they're telling us in the first statement, but a little bit differently. It says that the 10 digit of x equals to the 10 digit of y plus the 10 digit of x. The only way that the 10 digit of x can be equal to the 10 digit of y plus the 10 digit of x is the scenario that we just looked at, which was 7, 4, 5 and 3, 2, 7. Here the 10 digit is 3 and 10 digit is 2. Since their sum is less than 9, therefore, in that case, if their sum is less than 9, then and only then, the 10 digit of y, let's call this y and z, and this is your x, whatever this works out to be, doesn't really matter, whatever this works out to be. Oh, these are 3-digit numbers, what the hell? I was about to say that the 100 digit does not add up to what we need here. The 100 digit, the question is the 100 digit of x equal to the 100 digit of y plus 100 digit of z? The answer is yes, as long as the sum of the 10 digit is less than 9 is what we establish here. But the other condition is that these are all 3-digit integers, you see? So that doesn't work. Just change this to 2. Voila. So now, as long as the sum of the 10 digit of the two numbers is less than 9, then it will be true that their sum will equal to the 10 digit of x, which is what the first statement tells us. So the first statement is enough. First statement by itself does the job. Let's look at second statement. Because the first statement by itself is enough, A, D, B, C, E. Because the first statement by itself is enough, we know now that the answer cannot be B, C, or E. It will have to be either A or D. Okay? I'm not sure if I need to explain it one more time, but that's what it is. Let's look at second statement. In the second statement, let's see what they tell us. In the second statement, they're talking about unit digit. Unit digit of x equals to unit digit of y plus the unit digit of z. What this tells us is that the sum of the unit digits of y and z is something less than or equal to 9. That's what this tells us. This tells us that the sum of the unit digits of y and z is something less than or equal to 9. For example, we may have 343 and 525. As you can see here, 3 plus 5 will equal our 8. This is our x, this was our y, and z. But is that enough for us to know? Is that enough for us to know? What we want to know is the 100 digit of x, is the 100 digit of x, which in this case is 8, is the 100 digit of x equal to the 100 digit of y plus the 100 digit of z? 100 digit of y, which is 3, and 100 digit of z, which is 5. 3 plus 5 is 8. Yes, the answer in this case is yes. We're answering this question. The answer is yes. But what if we were dealing with something like this? Y equals 443 and z equals 900. I'm doing it again. It cannot be a 4-digit number. We don't need to change that. We need to change the middle one. 3, 5, and let's make it 5, 5. What if instead of 343, we only have to change. What if instead of 343 and 525, if the problem was such that y equals 353 and z equals 555. In other words, the sum of the 10 digit is not less than or equal to 9. The condition that we already discussed. You see here, the sum of the, that's what it boils down to. As long as the sum of the 10 digit is not less than or equal to 9, we will have a problem, because here we'll get a 9. Here we'll get a 9, and 9 of course does not equal 3 plus 5. So here the question is the 100 digit of x, equal to the sum of the 100 digit of y and z? The answer here is no. Answer here was yes. Second statement does not do it. Knowing something about the unit digit is of no use to us. It is not the unit digit that we are interested in. What's going to give us a problem is the 10 digit. We want to know if there is going to be any carryover from the 10 digit. If there is 100 being carried over from 10 digit, then the sum of the 100 digit is no longer going to be equal to the 100 digit of x, because 100 digit of x is going to be one more than that. 100 digit of x is going to be one more than the sum of the 100 digit of the other two. Like here, 100 digit here is 9, which is one more than the sum of the 100 digit of y and z, because we have 100 being carried over, and that is determined by the 10 digit. Unit digit has absolutely nothing to do with it. Second statement was worthless. Because the second statement is of no use to us, the answer is A. Second statement does not provide us, typically we say it does not provide us sufficient information. It provides us no useful information in this case. Alright? I'll see you tomorrow, okay? Bye now.